Well, here's another update to my keypad project. I wanted to show you a little bit about how all of this works, go into a little bit more detail about some stuff. So, in this drawing I have here, uh, it kind of shows the pinout of the Pro Micro that I've been using, um, and the different pins and where do they go. So here, it's in highlighter, so it's kind of hard to see. But essentially, anything in the yellow highlighter is pins that go to the matrix array of the 4x4 buttons. So there's 4 in and 4 out. So 1, 2, 3, 4 in, and 1, 2, 3, 4 out. I also have blue, the rotary encoders. So essentially, the actual rotary encoder portion of it, not the button press down portion, goes to these buttons. So you have rotary encoder 1 takes 2 buttons, and rotary encoder 2 takes the other 2 buttons. And so what you have there is pretty much the pinout for everything. You see also the pink here. There's for an SD card, there's voltage, ground, chip select, and clock, master in, slave out, master out, slave in. Those are the pins that will go off of this board. And I don't know if this will focus or not. Probably not. But essentially, those are the pins off of this little SD card reader. And what I'll be using that for is saving the configurations. So instead of having to reprogram this by using the Arduino IDE and dealing with C code and all that, all you have to do is take the SD card out, change the button assignments of what each button does on the SD card, and then push it back in, and it'll pull the information from there. It'll be a lot easier for other people to use. And so I wanted to go and show you one other thing. So essentially how the button array works. And so what we have here is you have your ins at each of these locations here, and your outs up here. So that's your 4x4. Those are the 8 pins that you'll be using. And essentially how this works is if you push a button, these are each of the buttons that you have. But essentially, pushing any one of those buttons closes the circuit. And so if I close the circuit here, this is essentially what happens with electricity. It comes in. Well, let me step back one last point to explain how these work in the code a little bit. Essentially, in the code, it cycles through each of these. So it'll turn one of these on at a time and then check each of the 4 outputs to see if anything was pressed. And then on the next time around, it'll do this and then check if any on this row was pressed. And just cycle through all of these until it sees anything pressed. So for example, this one got turned on, this to get closed. What happens is it follows the path here, goes through. This is going to be a diode, which is really kind of nice. So it hits this line, and essentially you can get some funny things happening if you don't have these diodes, but essentially it goes out here. The nice thing about diodes is this is all the same wire, so it can't go past the diode. Diodes is a one direction thing. So each of these kind of gets stopped at this diode. You see these little dots, these are interconnecting dots. When it goes across here, it kind of jumps over that wire type of thing to kind of give an idea of how this little schematic is shown. But essentially, that's how the matrix array works. It just cycles through the inputs and checks the outputs, and it works really pretty good for what I'm using. The other thing that you have here, which is kind of cool, is I'll try to explain the best I can the rotary encoder. So essentially, if you have 0 volts and 5 volts, as you rotate the rotary encoder, there's those 2 wires. And I'm going to say those 2 wires is A and B. And so what you have is, as I'm going to draw a couple lines here to indicate the clicks that happen. And so what happens here is, as you click through it, the B will go up and down through the clicks. And so it'll go from low to high to 5 volts there. And then for A, the other wire, it'll be just slightly different. So I'll go here, 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 here. So as you click through it, what happens, what you could do to see if it's going forward or backwards, we could count through here, and to know what direction, B goes higher than A goes higher. So if you're rotating in such a way that B goes high first and then A, you're going clockwise. Now, if you're going the opposite direction, A goes high and then B goes high, you're going counterclockwise. And those are the 2 directions you could go, and that's how you could determine what happens is by reading the voltage on A and B and then see which ones go high first. So that's kind of how the rotary encoder works. I hope that made sense. But anyway, I have the rotary encoder working. It works great. Right now I have it set up to work as the arrow keys, and so arrow left, arrow right, arrow up, and arrow down. And so for an example, you could go to a notepad or Google. I'm going to pull up Google Maps real quick. And so what you have here, I'm going to switch to this. And so on the rotary encoder, I could, need to click on the screen. Move, it's actually giving me a problem. So that's working, that's working, that's working. There we go. All right, now I'm moving the rotary encoder, and so you can move it back and forth or down and up, and it works pretty good. And so that's one way that you could use it. So you could tie it to all kinds of different things. You could have it zoom in, zoom out. You might tie it to like a history, and so maybe you're working Photoshop and you wanted to compare what you just did, and so you set it to the history of your Photoshop, and so you could go back and forth to do and undo and redo something, or you could zoom in, zoom out, or if you're doing photo editing, or not photo but video editing, you could move the timeline back and forth, and or so you could tie it to whatever kind of functions you might want it to do. But those are pretty much where I'm at that stage. So the next point would be getting the SD card reader working. So I'll get this hooked up. I ended up printing a little base for this. It was just something kind of quick. I'll end up printing another one because there's no hole for the SD card in this. There's just a little hole for the USB hookup for right now. But that's really pretty much it. I hope you like this project. If you want more details about how you actually work with an Arduino, work with the pins, and even some of the programming stuff, I could show you some of that kind of stuff as well. But I hope you liked it, and I'll see you later. Bye.